Hey, what's up everybody? This is Polynomials video number 7. This one is also on graphing, like number 6 was. This one will be focusing on zeros and factors. So, the zeros, polynomials, how to write factored form, things like that, you'll see coming up. So here we go. The first one I'm going to show you is an example of polynomial that I'm going to graph. The one here is x to the 4th minus x cubed minus 10x squared minus 8x. So this, of course, is in standard form. And so if I graph this, I'm going to use Desmos again because it's so much easier. And if I do that, it looks like this. So when I graph it, it looks like this. And I've already circled in green the 4 zeros. There, and there. Again, those are x-intercepts. So where the polynomial is 0, right where it hits this line right there. Those points, by the way, they are 4, 0, -1, and -2. Again, what's so awesome about using the iPad Desmos app is that you can just literally tap your finger on the points and they show you what they are. So much easier than the calculators. Again, if you want to learn how to do it there and you don't know how, ask me in class, I'll show you how to do it. You know, ACT tests, SAT tests, things like that, placement tests in college, you might have to use a calculator and do it a little longer way. So make sure you know how to do that too. But for this class, iPad's fine. So anyways, my zeros are, again, 4. 0, -1, and -2. And again, look at how it's x to the 4th, and I have 4 zeros. Again, that's not a coincidence. The power of your polynomial, your degree, usually tells you how many zeros you have. So then, those are my zeros. So then I can also write my factors from that. So my factors from that 0 being 4 is x minus 4. For the second one, since the 0 is 0, it's x minus 0, it's just x. The third one, -1 is the 0, so x plus 1 is the factor. And the fourth one is -2 is the 0, x plus 2 is the factor. So hopefully you notice that it's the opposite sign. So when the 0 is positive, the factor is negative, right? 0 is 0, so there's nothing extra, just x. For -1, it's the opposite, so it's x plus 1, and for -2, it's the opposite, so it's x plus 2. So this, you maybe also learned with quadratic forms a couple chapters ago, but this is called the factor theorem, which I'll show you on the next slide now. So this here I would add to your notes. This is called the factor theorem, again, and what this says is for any polynomial, if x minus a, this part here, if that's your factor, then a, so like positive a is a 0. So again, we realize that you have opposites between these two. So this is called the factor theorem, and it just tells you that, hey, if I find my zeros, I find factors. If I have factors, I also know my zeros. So going back to our last polynomial, right, this 4th degree one, since I have my 4 zeros, and then also my 4 factors, I can actually rewrite the polynomial just like this. X minus 4 times x plus 1 times x plus 2. If I FOILed all that out, I would get back to this polynomial here. So this is called the factored form. That E is terrible, I apologize for that. I'm going to redo that right now because I can. This is the factored form. So this one's, it's all factored, right? So factored form, obviously, whereas the one on top is written out in standard form, right? Highest power, lowest power, and it's all FOILed out in combined light terms, all that kind of good stuff there. So for example, let's say I have this polynomial here. I tell you the zeros are 5 and 0 and -1 and -3. Those are the zeros, the roots of the polynomial. So write this baby in factored form. So here's all I gotta do. Since my 0 is 5, then x minus 5 is the factor. So x minus 5 comes right here. Since 0 is a 0, now it's weird repetitive, but it is, it's x minus 0, so it's just x. Since -1 is a 0, that's x minus -1, which of course means x plus 1. And then -3 is a 0, so x minus -3, which of course means x plus 3 is a 0. So this again is factored form, I can't make E's on the iPad. Sorry about that. And that was just not English. So that's factored form. This polynomial here, if I want that in standard form, I can just FOIL it all out, right, and then figure out what I get. I'm not going to do that now. That was back in video 2 or 3, I believe. So for the next example, the zeros are 5, 6, 7, 6, and negative 1. So I can write this in factored form, because after all, the 0 is 5, so x minus 5 is your factor. Then for 6, it's x minus 6. Then for 7, of course, just x minus 7. It's that easy. Your 0 is 7, it's x minus 7, that's your factor. The next one's 6 again. Well, I list it twice, so I write it twice. And then negative 1, so that's x plus 1. So I can actually go a little bit quicker and do x minus 5, x minus 6. I have 2 of them, so it's squared. And then x minus 7 and x plus 1. And those, or this whole entire thing here, is the polynomial written in factored form based on the zeros. One more factor as well is that the zeros, 6 has what's called a multiplicity. I would note that. A multiplicity, I couldn't spell for some reason, of 2. So think about multiplicity, like the word multiple, because that 1, 0, 6 happens multiple times. How multiple? 2 times. So the multiplicity is 2. So you see this word multiplicity, that's how many times the zeros occur. So I would also note this in your notes, that multiplicity, because I might say that on a quiz or a test or a future assignment. Just know what that word means and at least have it noted for the future. Now I have one more example, and this is done. So lastly, go backwards. I'm giving you factored form, so find me the zeros. So what will the zeros be? Well, from this one, it's x plus 5. Think opposites. So one of my zeros is negative 5, or x-intercepts, right? From this one, a little tricky, I'll come back to that. This one, it's just x by itself. The 0 is 0, because it's x minus 0, right? Nothing's next to it. This one is x minus 1, 0, 0 is positive 1. Now back to this one here. To find the 0, here's what I do. 2x minus 3 equals 0. So I want to know, what do I plug in for x to make this factor 0? Like over here, I plug in negative 5 to x. Here I plug in 1. Here I plug in 0 to make it 0. So here I just solve the equation. So when I do that, I get 2x equals positive 3, add 3 on both sides. So from here, the 0 is 3 halves, or better known as 1.5. So these are the 4 zeros from that polynomial. So that's it for now. Any questions, let me know, and I'll see you in class. Thanks again for watching. I really appreciate it. Adios.